Now in this lecture we will find out the area of the semicircle using 4 different methods. In the drawing we have a semicircle that is inscribed by triangle ABC. Triangle ABC is a right triangle. Angle ABC, this angle equals to 90 degrees. Side CB of triangle ABC equals to 5 units. Side AB of triangle ABC equals to 12 units, and we want to find out the area of this semicircle. So we'll start with the first method, and we will define the center of this semicircle as point O. Actually, line segment OB, this line segment is the radius of this semicircle because of the fact that line segment OB starts from the center of this circle, that is to say from point O, and ends at point B, that is a point on the semicircle itself. Therefore, OB is the radius of this semicircle. We will define the radius of the semicircle as R. Therefore, OB equals to R. And what is the value of AO? As you can see from the drawing that line segment AO equals to AB minus OB. Again, AB minus OB equals to AO. So I'll write it down. AB minus OB equals to AO. So actually we know that AB equals to 12 units. It is given us in the question. And we found out that OB equals to the radius of the circle, of the semicircle, that is to say it equals to R. So actually, in conclusion, we found out that AO equals to 12 minus R. So we can write here that AO equals to 12 minus R. And we will define the point of tangency of tangent AC with this semicircle as point D. Then we will join together points D and O by a straight line. Actually, DO is the radius of this semicircle because of the fact that line segment DO starts from the center of the circle, that is from the center of the semicircle, that is to say from point O, and ends at point D, that is a point on the semicircle itself. Therefore, OD is the radius of this semicircle, that is to say it equals to R. In the next step, we will find out the length of the hypotenuse of triangle ABC according to the Pythagoras theorem. So we will focus on the right triangle, triangle ABC. On the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say AC square equals to the sum of the squares of the perpendiculars equals to CB square plus BA square. I will repeat again. In the right triangle, triangle ABC, according to the Pythagoras theorem, AC square equals to CB square plus BA square. So AC square equals to CB square. CB equals to 5 units, so CB square is 5 square. 5 square is 25 plus BA square. BA equals to 12 units. It is given as the question. So BA square is 12 square. 12 square is 144. So in conclusion, we found out that according to equation number 1, AC square equals to 25 plus 144. 25 plus 144 is 169. So we found out that AC square equals to 169. Here we'll take a root out of this equation, equation number 1, and we'll get that AC equals to the square root of 169. And the square root of 169 is 13. So we found out that according to equation number 1, AC equals to 13 units. So the hypotenuse of the right triangle ABC equals to 13 units. So we can write here that the hypotenuse AC equals to 13 units. And in the next step, I will present to you a new rule, rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I'll read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle, we have this circle, the center of this circle is at this point. We will define the center of the circle as point O, and we also have tangent. We have tangent to this circle here. AB is tangent to this circle at this point. We define the point of tendency as point M. So I write it down that M is the point of tendency of tangent AB with this circle. We will join points O and M together by a straight line. OM is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point O, and ends at point M, that is a point on the circle itself. Therefore OM is the radius of this circle, so we will define it as R, radius. And here you can see that the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore the tangent AB will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so whenever you have a radius that is drawn to the point of tendency like in this drawing, then the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So a tangent to a circle, that is to say AB, is perpendicular to the radius drawn to its point of tendency. The radius OM is drawn to the point of tendency, therefore the tangent AB will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so we can implement rule number 1 in our drawing. Because in our drawing we have the radius OD. Here the radius OD is drawn to point D, and point D is the point of tangency of tangent AC with this semicircle. So we have the radius OD that is drawn to point D, that is the point of tendency of tangent AC with this semicircle. Therefore the tangent AC will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so in the next step we will prove that the right big triangle, triangle ABC, is similar to the small right triangle, triangle ADO, or it is similar to the green right triangle, triangle ADO. Okay. So we will actually focus on the right triangle, triangle ABC, and on the right green triangle, triangle ADO. And we will prove that those two right triangles are similar to each other. Why they are similar to each other? First of all, we know that those two angles, they are equal to each other, they are both equal to 90 degrees, so we can write down that this angle, that is angle ABC in triangle ABC, is equal to this angle in the green triangle, that is actually angle ADO. So I'll repeat again. Angle ABC in triangle ABC is equal to angle ADO in the green triangle, and they are both equal to 90 degrees. And this angle is a common angle, it belongs to both triangles, it belongs to triangle ABC, and also this angle belongs also to the green triangle. So angle A equals to angle A is a common angle. that belongs to both triangles. I will repeat again. Angle A equals to angle A is a common angle that belongs to both triangles. And we actually have also those two angles that are equal to each other according to third angle theorem. So this angle that is actually angle ACB in triangle ABC equals to this angle that is actually angle AOD in the green triangle, and they are equal to each other according to third angle theorem. So I will repeat again. Angle ACB equals to angle AOB, and they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we have in triangle ABC, we have those two angles that congruent to those two angles in the green triangle. So we have in those two triangles two pairs of angles that congruent to each other. Therefore, the third pair of angles, those are defined as the third pair of angles, must be also congruent. That is to say, those two angles are equal to each other. And why they are equal to each other? Because they are complementary to 180 degrees. You know that the sum of the angles in any triangle is equal to 180 degrees. So if we have two pairs of angles that congruent in two triangles, then the third pair of angles must also congruent, because the third pair of angles are complementary to 180 degrees. Okay, so we actually prove that all three angles in triangle ABC congruent to all three angles to the green triangle. Therefore, we prove that triangle ABC is similar to triangle ADO according to angle similarity rule. So I write it down. Actually, we proved that triangle ABC is similar. This is the sign of similar to triangle ADO, the green triangle, according to angle similarity rule. I'll repeat again. Triangle ABC is similar to the green triangle, triangle ADO, according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all the angles in one triangle congruent to all the angles in another triangle, then you actually prove that those two triangles congruent to each other according to angle similarity rule. And from the fact that triangle ABC is similar to the green triangle, we will conclude that CB over CA in triangle ABC, CB over CA in triangle ABC equals to DO over AO in the green triangle. So I repeat again. CB over CA in triangle ABC equals to DO over AO in the green triangle. Okay? But we know that CB equals to 5 units, CA equals to 13 units, DO equals to R, and AO equals to 12 minus R. So in conclusion, we found out that according to equation number 2, 5 over 13 equals to R over 12 minus R. Here we will cross multiply equation number 2, and we will get that 5 times 12 minus R equals to 13R. Here we will open the brackets on this side of equation number 2, and we will get that 5 times 12 is 60, and 5 times minus R is equal to minus 5R. And it equals to 13R. Here we will add 5R to this equation, equation number 2, and we will get that 13R plus 5R is 18R. 18R equals to 60. Here we will divide equation number 2 by 18, and we will get that R, the radius of the semicircle, equals to 60 over 18. So here we will divide both the numerator and the denominator of this number by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle that we are looking for is equal to pi r square over 2. Okay, this is the sign for the area. I draw a semicircle inside the brackets. So the area of the semicircle equals to pi r square over 2. So it equals to pi, r is 10 over 3, r square is 10 over 3 square divided by 2. 10 over 3 square is 100 over 9. And 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of the semicircle according to a second method. First of all, I will not repeat on the things that I did in the first method. This point is point O, this is R, this is 12 minus R, AO. This is point D. DO is the radius of the semicircle, that is to say it equals to R. And okay, we know that we have already found out that the hypotenuse of the right triangle, triangle ABC, the hypotenuse AC equals to 13 units. So we will continue from this point to the second method. All those things we did in the first method. In the second method, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is called rule number 2, or 2 tangents theorem. So according to rule number 2, or 2 tangents theorem, the lengths of two tangents, the lengths of two tangents from a common external point to a circle are equal. So I'll repeat on rule number 2 again. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2 or two tangents theorem? The meaning of rule number 2 is that if we have a circle, okay, and we have external point, this point P, is defined as an external point in relation to this circle. Why it is an external point? Because point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore, it is defined as an external point of this circle. And if from the external point P we will draw two tangents to this circle, the first tangent will be this tangent, we will define the point of tangency of the first tangent with this circle as point A. So PA is the first tangent. Then we will draw a second tangent to this circle from point P, that is the common external point. And we will define the point of tangency of the second tangent with this circle as point B. So the second tangent is PB. And according to two tangents theorem, the length of two tangents, the length of the first tangent is PA. The length of the second tangent is PB. And according to two tangents theorem, the lengths of two tangents from a common external point, that is to say from the common external point P, to a circle are equal. That is to say PA is equal to PB, because PA is the length of the first tangent, PB is the length of the second tangent, and according to two tangent theorem, the lengths are equal to each other. That is to say PA equals to PB. So whenever you have a common external point to a circle and you draw two tangents to this to a circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. And we can actually implement rule number 2 or two tangent theorem in our drawing, because in our drawing we have the external point C, and from the external point C we have two tangents to this circle. The first tangent is tangent CB. CB is tangent to this semicircle at point B. So the first tangent is tangent CB. Actually, the length of the first tangent is CB. And the second tangent is tangent CD. Tangent CD is tangent to this semicircle at point D. And the length of tangent CD is CD. And according to rule number 2, the lengths are equal to each other. That is to say, CB equals to CD according to rule number 2. But we know it is given us the question that CB equals to 5 units. CB equals to 5 units. So we can write from this equation, we will derive that CD also equals to 5 units. Very simple. CD also equals to 5 units. Okay, and so we can write here that CD equals to 5 units. And we have already found out that CA equals to 13 units. It is the hypotenuse of the right triangle, triangle ABC. What is the length of AD? The length of AD is CA minus CD. Very simple. CA minus CD equals to AD. You can see it easily from the drawing. So CA minus CD equals to AD. I'll repeat again. CA minus CD equals to AD. So AD equals to CA is 13 units. It is the hypotenuse of the right triangle ABC that equals to 13 units. And we just right now found that CD equals to 5 units. So in conclusion, we found out that AD equals to 13 minus 5, and 13 minus 5 is 8. So we found out that AD equals to 8 units. So we can write down that AD equals to 8 units. And in the first method, we found out that those two angles are both right angles according to rule number 1. And because of the fact that angle ADO is a right angle, then triangle ADO is a right triangle. So the green triangle ADO is a right triangle because it has one angle that equals to 90 degrees. So we will focus on the right triangle ADO, and we will implement the Pythagoras theorem on the right triangle ADO. Okay, so in the right triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, and the hypotenuse on the green right triangle ADO is actually equal to AO. It equals to AO. The hypotenuse is AO because it is in front of the right angle. So the square of the hypotenuse is AO squared. And it equals to the sum of the squares of the perpendiculars, that is to say it equals to AD squared plus DO squared. So I'll repeat again. In the green right triangle ADO, according to the Pythagoras theorem, in the green right triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO square equals to AD square plus DO square. But we know that AO equals to 12 minus R, so AO square will be equal to 12 minus R square. And it equals to AD square. We have already found out that AD equals to 8, so AD square is 8 square. 8 square is 64. Plus DO square. DO equals to R. DO square will be equal to R square. So in conclusion, we found out that according to equation number 1, 12 minus r squared equals to 64 plus r squared. Here we will open the brackets on this side of equation number 1, and we will get that 12 minus r squared equals to 12 squared is 144 plus r squared minus 24r. And it equals to 64 plus r squared. Here we have r squared on both sides of equation number 1, so r squared will get cancelled. And what is left from equation number 1 after we cancel r squared? What is left from it is, in this side we have only 144 minus 24r, and in the other side we have 64. Here we will subtract 64 from this equation, equation number 1, and we will get that 144 minus 64 is 80, minus 24r equals to 0. Here we will add 24r to this equation, equation number 1, and we will get that 24r equals to 80. Here we will divide this equation, equation number 1, by 24. And we will get that the radius of the semicircle equals to 80 over 24. Here we will divide this number, 80 over 24, both the numerator and the denominator of this number by 8, and we will get that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units. And the area of the semicircle equals to this sign means the area. We have here a semicircle. The area of the semicircle equals to pi r squared over 2. So it is pi. R is 10 over 3, r squared is 10 over 3 squared, or divided by 2. 10 over 3 squared is 100 over 2, 100 over 9, divided by 2. 100 over 10, 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so we finished with the second method, and in the next step I will present to you how to find out the area of this semicircle according to a third method. And in the third method, I will draw a mirror image of this figure, and I will join this figure with its mirror image, and in this way we will get a circle that is inscribed by a triangle. Okay? So we'll do it now. We'll draw the mirror image of this circle, of this figure. So this side is the original image, and this side is the mirror image of this image, and we will define the vertex here as point D, and because of the fact that this side is the mirror image of this side, it means that AC must be equal to AD, and AC equals to 13 units, therefore AD must be also equal to 13 units. And BC must be also equal to BD. BC equals to 5, so BD must be also equal to 5 units. And DC, the base of the isosceles triangle ADC, equals to 5 plus 5, that is to say the base DC equals to 10 units. So here we will find out the area of this isosceles triangle ADC. The area of this isosceles triangle is equal to the base of the triangle times the height to the base over 2. This is the formula for the area of any triangle, and especially of triangle ADC. This is isosceles triangle. So the area of triangle ADC equals to the base of the triangle times the height to the base over 2. And the base of the isosceles triangle ADC is DC. The height to the base, so this is the base, and the height to the base is AB, because AB creates 90 degrees with the base, so for that reason it is the height. AB is the height over 2. And we have already found out that DC equals to 8 units. Yes, this equals to 10 units. This equals to 10 units. It is 5 plus 5, that equals to 10 units. AB equals to 12 units over 2. So the area of triangle ADC equals to 10 times 12 is 120. 120 over 2 is 60. So the area of the isosceles triangle ADC equals to 60 square units. And the radius of any circle that is inscribed by a triangle, like in this drawing, this circle is inscribed by triangle ADC. The area, the radius of the circle that is inscribed by a triangle will be equal to the area of the triangle that blocks the circle. In this example is triangle ADC over the semi-perimeter of the triangle that blocks the circle, that is also triangle ADC. So the radius of the circle that is inscribed by a triangle equals to the triangle that blocks the circle, that is actually triangle ADC, the isosceles triangle ADC, over the semi-perimeter of triangle ADC. And we have already found out that the area of triangle ADC equals to 60 square units, and the semi-perimeter of triangle ADC equals to the perimeter of triangle ADC over 2. And the perimeter of triangle ADC equals to AC plus AD plus DC over 2. I'll repeat again. The semi-perimeter of triangle ADC equals to the sum of its sides over 2. The sum of its sides is AC plus AD plus DC divided by 2 will give us the semi-perimeter. So the semi-perimeter of triangle ADC equals to AC that is 13 units plus AD that is also 13 units plus DC that is 10 units, all divided by 2. 13 plus 13 is 26 and 26 plus 10 is 36. 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC equals to 18 and the radius of the circle that is blocked by triangle ADC equals to 60 over 18. Here we will divide both the numerator and the denominator of this number by 6 and we will get that 60 over 6 is 10 and 18 over 6 is 3. So we found out that the radius of the circle equals to 10 over 3. That is also the radius of the semicircle because the circle composed of 2 times the semicircle. We combined the semicircle with its mirror image, so it is 2 times the semicircle, therefore the circle has the same radius as the semicircle. So the radius of the semicircle is 10 over 3 units and the area of the semicircle is pi r square over 2. So it is pi, r is 10 over 3. 10 over 3 square is r square, all divided by 2. So it is pi over 2. 10 over 3 square is 100 over 9. And 100 over 2 is 50. So we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay? So we finished with the third method. In the next step, I will present to you how to find out the area of the semicircle according to the fourth method. So here I will not repeat on the things that I did on the first and the second and the third method. This is point O, this is R, AO is 12 minus R. DO is the radius of the semicircle, that is to say it equals to R. We have this angle is a right angle, according to rule number 1, this angle it is also a right angle. AC equals to 13 units. And we will define angle CAB or BAC as angle theta. And we will focus on the right triangle, triangle ABC. On the right triangle, triangle ABC, sinus theta equals to CB over CA. I repeat again, on the right triangle, triangle ABC, sinus theta equals to CB over CA. But we know that CB equals to 5 units. It is given us in the question. And we have already found out that the hypotenuse CA of triangle ABC equals to 13 units. So in conclusion, we found out that sinus theta according to equation number 1 equals to 5 over 13. I repeat again, sinus theta according to equation number 1 equals to 5 over 13. In the next step we will focus On the right, triangle ADO. On the right, green triangle ADO. On the right, green triangle ADO. Sinus theta. Sinus theta equals to, here this point is point D, and this is R. Okay, sinus theta equals to DO over AO. I repeat again, on the right, green triangle ADO. Sinus theta equals to DO over AO. So sinus theta, according to equation number 2, equals to DO is equal to R, it is the radius of the semicircle. AO equals to 12 minus R. So in conclusion, we found out that according to equation number 2, sinus theta equals to R over 12 minus R. We will create equation number 3. Equation number 3 states that sinus theta according to equation number 1 that equals to 5 over 13 must be equal to sinus theta according to equation number 2 that equals to R over 12 minus R. Okay, so equation number 3 states that sinus theta according to equation number 1 equals to sinus theta according to equation number 2. Okay, and we will cross multiply equation number 3, and we will get that according to equation number 3, 5 times 12 minus R equals to 13R. Here we will open the brackets on this side of equation number 3, and we will get that 5 times 12 is 60, and 5 times minus R is minus 5R, and it equals to 13R. Here we will add 5R to this equation, equation number 3, and we will get that 13R plus 5R is 18R, and 18R equals to 60 because 5R minus 5R is 0, so we left in this side of the equation only with 60. In conclusion, we found out that according to equation number 3, 18R equals to 60. Here we will divide equation number 3 by 18, and we will get that the radius of the semicircle equals to 60 over 18. R equals to 60 over 18. Here we will divide this number, both the numerator and the denominator of this number, by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle equals to pi r squared over 2. Pi r squared over 2. So it is pi, and r is 10 over 3. R squared is 10 over 3 squared over 2 divided by 2. So 10 over 3 squared is 100 over 9. Hundred over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so we finished with the fourth method. In the next step, I will summarize the lecture. Actually, we found the area of the semicircle in 4 different ways. And in the first method, I repeat again on the question. We have here a semicircle that is inscribed by triangle ABC, that is a right triangle. CB equals to 5 units, AB equals to 12 units, angle ABC equals to 90 degrees. And we want to find out the area of this semicircle that is inscribed by triangle ABC. Okay, we defined the center of the semicircle as point O. OB is the radius, and because of the fact that it starts from the center of the circle and ends at point B, that is the point on the semicircle itself, therefore OB is the radius of the semicircle. And what is the value of line segment AO? AO equals to AB minus OB. Again, AO equals to AB minus OB. So AB equals to 12 units, this is given us in the question, and OB equals to R. So in conclusion, we found out that AO equals to 12 minus R, AO equals to 12 minus R. Then we implemented the Pythagoras theorem on the right triangle, the right big triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the right triangle ABC, it means that AC square equals to CB square plus BA square. AC square equals to CB square. CB is 5, so CB square is 5 square. 5 square is 25. Plus BA square. BA equals to 12, so BA square is 12 square. 12 square is 144. So AC square equals to, according to equation number 1, AC square equals to 25 plus 124. 25 plus 140, 25 plus 144 is equals to 269. Again, AC square equals to 25 plus 144, and 25 plus 144 is equals to 169. So AC square equals to 169. We took a root out of this equation, equation number 1, and we found out that AC equals to the square root of 169. The square root of 169 is 13, so we found out that the hypotenuse AC of the right triangle, triangle ABC equals to 13 units. AC equals to 13 units. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. What is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle, and this is the center of this circle is at point O, and tangent AB is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle. Then you can see here that the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius. That is to say, I'll repeat again, this angle equals to 90 degrees and this angle also equals to 90 degrees. The radius OM is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So we can implement rule number 1 in our drawing, because in our drawing we have point D is the point of tangency A with this semicircle, and we have the radius OD, it is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of tangent AC with this circle. Therefore, the tangent AC will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So whenever you have a radius that is drawn to the point of tendency, like in this drawing, then the tangent will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? So here we have the green triangle is a right triangle because this angle equals to 90 degrees. Then we actually proved that the right triangle, the right big triangle, triangle ABC, is similar to the small green right triangle. Why they are similar to each other? Because of the fact that angle ABC equals to angle ADO equals to 90 degrees. Those two angles, they are both right angles, they are equal to 90 degrees. Angle A equals to angle A. It is a common angle that belongs to both triangles. And those two angles are also equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. So we have here those two angles in triangle ABC congruent to those two angles in the green triangle. Therefore, we have actually here two pairs of angles that congruent in those two triangles. Therefore, the third pair of angles, that is to say, those are the third pair of angles that must also congruent, that is to say, those two angles are equal to each other. Why they are equal to each other? Because we have two pairs of angles that congruent in those two triangles, and the third pair of angles is complementary to 180 degrees. The sum of the angles in any triangle is 180 degrees. Therefore, the third pair of angles, they are complementary angles to 180 degrees. Therefore, they must be equal to each other. Okay, so we actually proved that all three angles in triangle ABC congruent to all three angles in the green triangle. Therefore, we proved that triangle ABC is similar to triangle ADO according to angle similarity rule. And from the fact that those two triangles congruent to each other, we will conclude that CB over CA in triangle ABC equals to DO over AO in the green triangle. CB equals to 5 units, CA equals to 13 units, DO equals to R, and AO equals to F minus R. So we got that according to equation number 2, 5 over 13 equals to R over 2F minus R. We cross multiplied the equation number 2 and we got that 5 times 2F minus R equals to 13R. We open the brackets on this side of equation number 2 and we got that 5 times 12 is 60, 5 times minus R is minus 5R, and it equals to 13R. We added 5R to this equation, equation number 2, and we got that 13R plus 5R is 18R. In conclusion, we got that 18R equals to 60. We divided this equation, equation number 2 by 18, and we got that the radius of the semicircle equals to 60 over 18. Here we divided both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we got that the radius of the semicircle equals to 10 over 3. And therefore, the area of the semicircle equals to pi r square over 2. So r is 10 over 3, so r square is 10 over 3 square. And 10 over 3 square is 100 over 2, and is 100 over 9, and 100 over 2 here is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so we actually finished with the first method. Then I presented to you how to find out the area of the semicircle according to a second method. In the second method, I presented to you rule number 2. According to rule number 2, or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and we have external point P is an external point of this circle, and if from the external point P we draw two tangents to this circle, the first tangent is tangent PA, the second tangent is tangent PB, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. So the lengths of two tangents, that is to say PA and PB, from a common external point, that is to say from point P that is a common external point to a circle, are equal. That is to say PA equals to PB. So whenever you draw two tangents to a circle from a common external point, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. We can implement rule number 2 in our drawing, because in our drawing we have the external point C of this semicircle, and from point C we have two tangents to this circle. The first tangent is tangent CB, the second tangent is tangent CD, and according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, CB equals to CD. Okay, so according to rule number 2, CB equals to CD, but we know that CB equals to 5 units, so we can write here that CB equals to 5 units. From this equation we will derive that CD also equals to 5 units. CD equals to 5 units. But we already found out that CA equals to 13 units, and we just right now found that CD equals to 5 units. So AD will be equal to CA minus CD. Okay, AD equals to CA minus CD. CA equals to 13 units, and we just right now found that CD equals to 5 units. So in conclusion, AD equals to 13 minus 5, that is to say AD equals to 8 units. So we found out that AD equals to 8 units. And then we can implement the Pythagoras theorem on the right green triangle, triangle ADO. According to the Pythagoras theorem, in the right green triangle, triangle ADO, AO square equals to AD square plus DO square. AO equals to 12 minus R, so AO square will be equal to 12 minus R square. AD equals to 8, so AD square will be equal to 8 square. 8 square is 64, plus DO square. DO equals to R, so DO square equals to R square. Here we open the brackets of this side of equation number 1, and we got that 12 minus R equals to 12R, that is 144, plus R square minus 24R, and it equals to 64 plus R square. We have R square on both sides of this equation, equation number 1, so R square will get cancelled. And what is left from equation number 1 after we cancelled R square? What is left in this side? What is left, it is actually 144 minus 24R, and on the other side we left only with 64. We subtracted 64 from this equation, equation number 1, and we got that 144 minus 64 is 80. So in this side we have left with 80 minus 24, and here 64 minus 64 is 0. So in conclusion we found out that 80 minus 24R equals to 0. We added 24R to this equation, equation number 1, and we got that 24R equals to 80. We divided this equation, equation number 1 by 24, and we got that R, the radius of the semicircle, equals to 80 over 24. We divided both the numerator and the denominator of this number by 8, and we got that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle equals to pi r square over 2. R is 10 over 3. R square is 10 over 3 square, and 10 over 3 square is 100 over 9. So in conclusion, we got that the radius of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so we finished with the second method. In the next step, I will present to you how we found out the area of this semicircle according to a third method. In the third method, I drew this the window. I drew the this image. I drew the mirror image of this figure. I drew the mirror image of this figure, and I joined this figure with its mirror image, and in this way we got a circle that is inscribed by a triangle. Here, this is actually this part of the drawing is the original image, and I draw beside it the mirror image of this image, and we got this circle that is described by triangle ADC. And we know that AC equals to 13 units, therefore AD must be also equal to 13 units, because those two parts are the mirror image of each other, and DC equals to 5 units, therefore DB will be also equal to 5 units, and AB equals to 12 units. It is given us in the question. So the area of this isosceles triangle ADC equals to the base of the triangle times the height to the base over 2. The base of triangle ADC equals to DC. The height to the base is AB over 2. DC equals to 10 units, AB equals to 12 units. So in conclusion, the area of the isosceles triangle ADC equals to 10 times 12 over 2. 10 times 12 is 120, and 120 over 2 is 60. So we found out that the area of the isosceles triangle ADC equals to 60 units, to 60 square units, and the radius of the circle that is inscribed by triangle ADC equals to the area of the triangle that blocks this circle, that is actually the area of triangle ADC, that equals to 60 square units over the semi-perimeter of this triangle ADC. And the semi-perimeter, I'll repeat again, the radius of the circle that is inscribed by triangle ADC, the circle is inscribed by triangle ADC, and the radius of the circle that is inscribed by triangle ADC equals to the area of triangle ADC over the semi-perimeter of triangle ADC. Okay? And we have already found out that the area of triangle ADC equals to 60, and the semi-perimeter of triangle ADC equals to the perimeter of triangle ADC over 2. The perimeter of triangle ADC equals to AC plus AD plus DC. And if we divide it by 2, we will get the perimeter, the semi-perimeter. So the semi-perimeter of triangle ADC equals to AC that is 13 plus AD that is also 13 plus DC that is 10, all divided by 2. 13 plus 14 is 26. 26 plus 10 is 36. And 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC is 18. Therefore, the radius of the circle that triangle ADC blocks will be equal to the area of triangle ADC that is 60 square units over the semi-perimeter of triangle ADC that is 18. And so the radius equals to 60 over 18. We divided both the numerator and the denominator of this number by 6. 60 over 6 is 8. And 18 over 6 is 3. So we found out that the radius of the circle equals to 10 over 3 units. That is also the radius of the semicircle. And the area of the semicircle equals to pi r square over 2. R is 10 over 3. R square is 10 over 3 square. and 10 over 3 square is 100 over 9. Here we have 100 over 2 is 50, so we found out that the radius of the semicircle according to the fourth method equals to 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. It is actually the area of the semicircle according to a third method, and we actually found out the area of the semicircle according to a fourth method. In the fourth method, we actually find angle CAB, this angle is angle theta. Then we focused on triangle ABC. On triangle ABC, the right triangle, triangle ABC, we know that sinus theta equals to CB over CA. I'll repeat again. On triangle ABC, sinus theta equals to CB over CA. CB equals to 5 units. CA equals to 13 units. So in conclusion, we found out that according to equation number 1, sinus theta equals to 5 over 13. Then we focused on the right green triangle, triangle ADO. In this right green triangle, triangle ADO, sinus theta equals to DO over AO. I'll repeat again. In the right green triangle, triangle ADO, sinus theta equals to DO over AO. DO equals to R, AO equals to 12 minus R. So sinus theta equals to R over 12 minus R. And we created equation number 3 that states that sinus theta according to equation number 1 must be equal to sinus theta according to equation number 2. So sinus theta according to equation number 1 is 5 over 13, and it must be equal to sinus theta according to equation number 2, that is R over 12 minus R. So here we cross multiplied equation number 3, and we got that 5 times 12 minus R equals to 13R. We open the brackets on this side of equation number 3, and we got that 5 times 12 is 60. 5 times minus R is minus 5R. So in conclusion, we found out that 60 minus 5R equals to 13R. We added 5R to this equation, equation number 3, and we got that 13R plus 5R is 18R, and 18R equals to 60. According to equation number 3, we divided this equation, equation number 3, by 18, and we got that the radius of the semicircle R equals to 60 over 18. We divided both the numerator and the denominator of this number by 6, and we got that 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units, and then the area of the semicircle equals to pi r squared over 2. This is the sign of the area. It means the area of the semicircle. It equals to pi r squared over 2. R equals to 10 over 3. R squared equals to 10 over 3 squared. 10 over 3 squared is 100 over 9. And here we have 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, thank you very much.